Scientists found a runaway black hole buried in a Hubble image. Look at this archival Hubble image. See anything weird? There are multiple galaxies strewn around the picture as you'd expect, and a lot of artifacts thanks to cosmic rays. Hubble takes pictures in black and white, and then scientists color the photo based on the filters used. There can be a lot of noise in Hubble images. Here's the original black and white photo from the Hubble archives. It was taken on September 5th, 2022, with around 42 minutes of exposure time. The image was intended to be of the dwarf galaxy RCP-28, and the scientists were originally looking for data on the aftermath of a high-speed collision between galaxies that may have left them without dark matter. Remember, dark matter is what holds galaxies together. When they were examining this photo in particular, they originally dismissed the streak as a cosmic ray artifact that hadn't been properly removed. But when they looked at the image under a separate filter, they saw the same streak, which shouldn't have happened. Something was going on here. Under spectroscopic observation, they realized that the streak was in fact a supermassive black hole traveling through intergalactic space, or the space between galaxies. There's a paper on this discovery in the Journal of Astrophysical Letters. The black hole itself has the mass of 20 million of our suns. In comparison, Sagittarius A star, the supermassive black hole at the center of the Milky Way, has the mass about 4.3 million of our suns. The black hole is traveling so fast, it could cross the distance from the Earth to the Moon in about 14 minutes. You can't see the black hole itself, but what you can see is a slightly wider, brighter end, and that's the luminous event horizon surrounding the black hole. The trail is actually new star formation that's happening in the black hole's wake as it travels through space. The trail of new stars is about 200,000 light years long. The scale of this entire image is about 1.4 million light years across. The object is about 7.669 billion light years away. Scientists think the object was ejected from the galaxy to the top right of the black hole trail. How can new stars form in the wake of a black hole? Doesn't a black hole suck in everything and nothing can escape, not even light? Well, yes and no. If a black hole with the mass of our sun were to take the place of our sun, Earth would stay the same. I mean, all life would die as a result of losing our host star, but the planet would stay right here. It wouldn't get sucked into the black hole. The area a black hole affects is dependent on its mass. Outside that area, space and matter just exist as normal. This star trail is outside that area, especially as a black hole moves quickly through space. It's moving so fast that it's basically plowing through gas and not really stopping to have a snack. In the wake of the black hole, the gas cools enough to trigger star formation. Scientists have never actually seen anything like this, so it's pretty cool. Considering we can see the trail of stars from 7 billion light years away, there must be a lot of them. So now the question is, how does this happen? How does a black hole get kicked out of its host galaxy? Scientists think that around 50 million years ago, two galaxies merged. That meant their supermassive black holes interacted, which probably formed a binary supermassive black hole in which the black holes orbited one another. Then a third galaxy came along and destabilized this delicate dance. This interaction between the three black holes meant that all three went flinging out. One went one direction and the other two went the opposite direction. The single supermassive black hole is leading the trail of stars, and you may actually be able to see the binary on the other side of the original host galaxy. Scientists aren't certain about this, but observations show that the original galaxy no longer has a supermassive black hole at its center. They're already scheduling follow-up observations to confirm this theory.